All right, next up we have sp2 hybridization. And so sp2 hybridization, right? One S, two Ps, that's three things attached to our central atom. So maybe something like this formaldehyde, right? This carbon right here in the center has one, two, three things attached to it. Or maybe this BH3 has one, two, three things attached to it. And so they're both sp2 hybridized. This oxygen also, right, it has multiple bonds to a central atom. So it's terminal, but it has multiple bonds to a central atom. And so it hybridizes as well. And so it has one, the carbon, two, a lone pair, and then three, another lone pair. So that's also sp2 hybridized. Right, again, the name sp2 hybridization implies one s orbital and two p orbitals. And so you have your sphere and then two of your dumbbells all mixing together. And when they mix together, you get three sp3 orbitals. Or three sp2 orbitals, my bad. And these two, each individual sp2 orbital also does have this kind of little tail end that is rarely shown, right? So there's one on the bottom, three of them on the top. And so what you might notice is that you have one leftover p orbital. Right, one of these orbitals did not hybridize, right? So this p orbital here, in this case, did not hybridize. And so let's see what's going to happen with these orbitals. So let's take a look at ethylene. We can see that both of these carbons have three things attached. So they're both sp2 hybridized carbons. And so we can do carbon, carbon, and they need to have three sp2 orbitals. So the first one will be with each other, right? That's one sp2 orbital. Then we have another sp2 orbital kind of coming out of the board, and then one going back into the board to form that trigonal planar shape. And then same thing on this other side. And each one of these orbitals has one electron in it. And then we have hydrogen that has this direct overlap. Right, and so far what we've accounted for is all of our sigma bonds, right? All these in blue, we've drawn all of these, right? A single bond between the two carbons and single bonds between the carbons and the hydrogens. Those are our sigma bonds. But then each one of these carbons has a leftover orbital on it, right? It has an unhybridized p orbital that has one electron in each of them. And so these two can actually bond from a distance. They're overlapping, but they're not directly overlapping. They're not directly touching, but they can still interact with one another. And so this is your pi bond right here, right? And so that pi bond is right there. And so these pictures are a bit tough to draw. So I've got a little kind of better image here for you. If I could get it on here. Let's move down here. So you can see how they're both showing the same thing, right? Here's all your sigma bonds. And then here, this one's showing your pi bonds, this indirect overlap between these two. And then when you combine them all together, you get the complete structure here. So one thing that you should notice here is that we can no longer rotate. If we were to rotate, we would break this bond right here. And so we can't break that bond. And so we are no longer allowed to rotate. And so this compound here has 5 sigma bonds and then 1 pi bond. Let's take a look at a different compound, the formaldehyde that we drew in the beginning. right? And so in this case, they're both, the oxygen and the hydrogen are both sp2 hybridized. They both have three things about them. And so we can draw our oxygen up here, our carbon down here, and then we have direct overlap of one of these sp2 bonds. And then we have two more sp2 bonds. In the case of oxygen, these two are going to be filled by the lone pairs of oxygen. In the case of carbon, there will be one electron in each, and then they'll be overlapped by the hydrogens. And so that takes care of all of our sigma bonds. And then we have one leftover p orbital, right? In this case, this p orbital would be coming kind of out of the board. Half the lobe would be coming out of the board, and then the other half would be going directly back into the board, right? So coming out of the board, and then back into the board. I probably should have drawn that in a different color, huh? Make a different color, red. Right, coming out of the board, going into the back of the board, coming out of the board, going to the back of the board. They have one electron each, and so then we can form a pi bond right there, which explains that right there. So in this case, our molecule has three sigma bonds, and then one pi bond.